Alright guys, we want to talk about the trapezoid mid-segment on this video. So let's go and construct a trapezoid. Remember, construction, we need a segment, we need a point not on that segment, we'll call that point C, okay? Then we need to construct a line parallel to AB, going through C, parallel to AB, okay? And then we need to put a point on that parallel line, needing more tools, point on, point tool, okay, on object, okay, and then we need to construct our segments, going through to form our trapezoid, okay, and then we can come back and we can hide this parallel segment, hide that, and then we'll finish off with the segment between C and D. Okay, so this is now a trapezoid, okay, in that it is constructed with one set of parallel sides, and these set of sides that are parallel, CD and AB, are of course what we call the bases. Okay, the legs then, the legs are the non-parallel sides, and of course we have what we call a mid-segment, which is a segment that goes and connects the midpoints of the legs. So we've got to go to midpoint tool, okay, find the midpoint of each, okay, find the midpoint of each, and then connect those with a segment, okay, connect those with a segment, and EF is now our mid-segment. That is, E is the midpoint of the leg AC, and D is the midpoint of, F is the midpoint of DB, and EF is the midsegment. Now, the theorem that we're concerned with here is the theorem that says the midsegment of the trapezoid, okay, is parallel to each base, so we'll check for that by measuring its slope, okay, and so we measure the slope there, it's a half, the slope here is a half, and the slope there is a half, okay, so that confirms. And of course, if I were to manipulate this in any which way, okay, as we do here, okay, we're seeing that the slopes are remaining equal, okay, so there's my equal slopes, okay. So that confirms that the mid-segment is parallel to each of the bases. Now it also says that its length is the average of the two. Okay, so if I measure the length of from C to D, that's 1.5. From A to B is, let's see, measure that again. Measure from A to B. Not wanting to cooperate, okay, for some reason. Back and undo this a little bit, okay. Measure distance or length. Select 2 points from A to B is length 4.7, and from C to D is 1.5. Now, if I add those two together, 4.7 and 1.5, 4.7 and 1.5 added together is 6.2, and half of 6.2 should be what this length EF is, okay, which is 3.1. So that confirms that. So the mid-segment is parallel to each base and half its length, parallel to each base and half its length. So again, regardless of how I manipulate this, okay, we can always confirm that if I add, okay, here, 8 and 2.5, 8 and 2.5, that is 10.5, and half of that is 5.25, which this is, but it's just not showing the second decimal place, okay? So, all right, what we want you to do for the exercises, as we're going to show you here, okay, is that, okay, we're going to ask you a couple things. We're going to ask you to plot these points out, okay? We're going to ask you to plot these points out, just plot them in place, okay, to draw your trapezoid. Then we're going to ask you okay, to compute those things by hand using the formulas. We've done these before. You've done these for triangle midsegment, so you certainly shouldn't have any issues here. Just plot the points, okay? All right, and just once the points are plotted, okay, use the formulas for slopes, okay, and show that the midsegment is parallel to the base and half the length is half the sum of the two bases. Again, that means from the picture over here, okay, in order to find EF, we have to add AB and CD, add them together and take half, and that should be the length of that. So that's what we're dealing with what we call the trapezoid midsegment, okay? And that should help with the exercises that I'm asking you to do. Okay, that's it.